Hi, Dave Smith here. So this is the next video in my Getting Ready for Wet Plate series, and we're talking developers. You see I've got some brightly coloured chemicals here. I've got this little liquid here. We're missing a liquid. I don't have the fourth ingredient with me right now. So let's talk about developer. So essentially the developer is iron 2 sulfate. Now, iron 2 sulfate oxidizes readily to iron 3 sulfate. My understanding is that either will do. The tendency is to use iron 2. I haven't tested iron 3 and there's really not very much information around. But I believe it will continue to work. So when you make this solution, it'll be a pale green like this. When it oxidizes to iron 3, it's a red, a bit like iron oxide, which is rust. Now in this form, sort of dry, just sitting there, it's perfectly stable. It won't easily oxidize into iron 3. But you put it into water, my word, it oxidizes quickly. One way to prevent that is to acidify the water. We want to acidify the developer anyway, because you don't want an acid-base reaction when you put your developer onto your plate. So what we use is the chemical I haven't got here, which is acetic acid. Now there are two ways to do this. You can get yourself some glacial acetic acid and dilute it. Glacial acetic acid is, I believe, 40%. You want something like a 5% solution. Now it turns out that white vinegar is actually a 6% acetic acid solution, perfectly fine. And that's indeed what I'm going to use. I'm going to use standard white distilled white vinegar at a 5 or 6% solution to make my developer with. That's the stuff I haven't got with me right now. And the thing is, if you're going to make this with glacial acetic acid, then put the acid into the water first, so that when you add your iron 2 sulfate, it doesn't instantly oxidize to iron 3. I don't think it matters, but just in case. But if you're using white vinegar, then it's already water and acetic acid mixed, so it's already acidified. You can just put that straight in. The other chemical you need is ethanol. Now this is bioethanol. Now you use ethanol in lots of places in this process. You use it if you're making up your own salted collodion, which indeed I will be doing. Collodion is on its way. And I'll do videos about all of this stuff as we go along. So you use ethanol. You also need diethyl ether. Now that's a bit less easy to come by, but you can order it from Amazon for it, I believe, Amazon. So it is obtainable. But there are recipes that don't use additional ether, but you do need ethanol. Now, excuse me, there are lots of discussions online about the ethanol, and ethanol is a funny substance. It's essentially pure alcohol. When you go down to the pub to get a weekly hit of something, it's the ethanol that you're essentially drinking. And so because it's a pure alcohol, it's got excise duty on it, and that makes it pretty expensive. It's also quite difficult to get hold of, and don't imagine that you need a pure form. 96% is as good as you're going to get. When you buy it, other than as pure alcohol, which is expensive and it's difficult to get, I believe you need a license, for example. But if you buy just this stuff from the supermarket or Amazon or wherever, it's what's called denatured. So they've added poison, really, to prevent it from being drinkable. It won't kill you. If you drink it, it's like an emetic. It causes you to throw up. So it just makes it not drinkable. Now, what they use to denature it can have some kind of effect. I don't know what's been used to denature this, but the key really is that there's no colorant in it. It will be denatured. This one is a 1% denaturing, so it's not terribly polluted, if you like. So I'm going to try that anyway. I'm pretty certain that's going to be absolutely fine. I think some people go a bit overboard with keeping things traditional, like the potassium cyanide fixer we spoke about before. I think one of the main reasons that many people use that is because that's what was used when this process was first sort of invented and widespread use. It's what they used. So I think partly people use it for that reason. But this ethanol will be perfectly fine. Now the third chemical I've got here is copper sulfate, and because some developer recipes have some copper sulfate in them, I don't know what difference that will make, but I'm going to try both, and as ever, as we get into this, I'll show you the differences and what happens. But I just want to say a couple of things about health and safety. Copper sulfate is a pretty nasty chemical. We come across it all the time, so we tend to take a benign view of it, but it's a bad chemical. It's not make you blind bad like silver nitrate, but it's something to be wary of. So if you're using it, wear goggles. You do not want to get that stuff in your eye. It won't make you go blind, but it won't be a pleasant experience either. So wear goggles. If you splash copper sulfate on your clothes, don't just wipe it off. All right? If you wipe it and leave it to dry, you put that in the washing machine, comes out, there'll be no fabric left where the copper sulfate was. It will just be eroded. So if you do spill it on, thoroughly rinse your clothes and get rid of it completely. Otherwise, you're going to be throwing your shirt away. And I do speak from experience there. Okay. I'm not sure about iron sulfate, but I'm pretty certain that that's going to be an equally dodgy chemical. And of course, the big thing about these is, well, look at them. They're brightly coloured. So if you've got young children, they're going to see those and think sherbet. Okay, so if you're using these things at home, there's no two ways about it. Make sure that it's locked away, not just up high on a shelf somewhere, okay, but actually locked away. You do not want your youngsters getting into these chemicals, okay? Don't let that put you off. You make the risk assessment, understand what the risks are, and then take appropriate precautions. Okay, it's not difficult to have a cabinet that you can lock, keep this stuff out of the way of youngsters, because they will get into it if they can. And, young kids are inquisitive, so understand the risks, take the precautions, make sure everybody's safe. Okay, so that's it for developer. I will gather together all of these recipes and I'll put them somewhere, probably on my website. And once I've done that, I'll give you a link to that so you can find these various recipes for yourself. Okay, so we are coming to the end of this Getting Ready series. There are one or two more videos I want to make on it, but we're heading towards the doing. So more of that in the next video. So thanks for watching. Bye for now.